Alright guys, I just decided to record a video. It's just separate after you guys all left because I feel like, I don't know, it'll be easier to have it all in one video anyway. And then also I want to go through each one of these things, talking about how to solve it algebraically. Later we're going to use the calculator, but algebraically it matters because it's actually how you make sense of it. If you're going to solve it algebraically, it's got to make sense in the context of the question. So we're just going to go through this. We're not going to start off by graphing it. We're not graphing it at all. We're going to do it all algebraic. So it says, an arrow is shot upward with an initial velocity of 64 feet per second from a platform that is 32 feet high. The height of the arrow is determined by h of t equals 32 plus 64t minus 16t squared, where t is the time in seconds and h is the height in feet. So it's important to realize that this is simply an equation comparing the height, which is this h of t, given the time, which is this t variable right here. And you'll notice that every single question that's possible that they ask is based on the idea that they're giving us some piece of information about height or time, and we're using it to figure out whatever they're asking. So for example, this first one, B, it says, where is the arrow at 2.5 seconds? So the piece of information that they gave me was a time. I'm going to use that. They gave me a time. They gave me a t. I'm going to use it to find the height or the where. All right, so starting off, B, using this equation, it says where is the arrow? So we're solving for the h of t part. Where is the arrow? 32 plus 64, and you'll notice I'm just rewriting this equation. 64 at time 2.5. So instead of writing t, I'm going to write 2.5 minus 16 times 2.5 squared. Okay, so when I plug this into the calculator and solve it out, or maybe you want to do it by hand, which would take forever, your answer should come out to be 92 feet. So, in other words, 32 plus 64 times 2.5 minus 16 times 6.25, which that's 2.5 squared, equals 92 feet. Okay, so that's the first question answered. Next question, it asks, when is the arrow at 32 feet? All right, so that's a height. We're still referencing this same equation, except now they give us a height. And this gets a little bit trickier. So I'm going to go ahead and work in red real quick, just so I can alternate. But when is the arrow? So when is the height? When is the height 32? So I'm going to set height equal to 32. And then I'm going to rewrite this the rest of this equation and solve for my t's. 32 plus 64t minus 16t squared. Okay, to solve for t, I can either factor or I can use the quadratic equation. Typically, I just always use the quadratic equation and don't even worry about anything else. So I'm going to subtract 32 from each side, which is going to cancel these 32's out. And I'm going to be left with, and notice real quick, I'm going to take this negative 16t squared, I'm going to write it first. Negative 16t squared plus 64t, just because you guys are more used to seeing t squared plus t and then plus some c value over here. So I'm going to write it in that order. And I'm going to go ahead and use the quadratic equation. But hold on, before I do, I'm going to give you an example of factoring. So here's factoring, just a little side note. If I wanted to factor this, I would notice that 64 and 16 can both be divided by 16. So I'm going to divide negative 16 out of this. Also, they both have a t offered up that they can give. So they're going to give a t. So I'm going to divide negative 16t out of both of these terms. That's going to leave me with the left term, simply just a t, and on the right term, a minus 4, and that equals 0. And the only two ways that if I'm going to multiply negative 16t by t minus 4, the only two ways I can get 0 is if t equaled 0 or t equaled the opposite of 4. Okay, so that would actually solve it. So I've already solved c, but I'm going to show you using the quadratic formula also. So notice, here's my answers by factoring. Sometimes it's easier to factor, but not everything's factorable. Everything you can use the quadratic formula on. So quadratic formula, that's negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so negative b, that's going to be negative 64. Negative 64 plus or minus the square root of 64 squared minus 4 times a, which is negative 16, times c, which is, there is no c, so it's 0. All of it over 2 times a, so 2 times negative 16. So here's something. I watched you guys struggle with this all day today. Here's something that will make it very, very easy for you. I'm going to go ahead and zoom in on this. So notice, you can just type it in straight into the calculator, like just like you see it. I mean, sorry, over here, just like you see it here. So I'm going to just type it straight into the calculator just like that. So what I see above. Okay, so I'm going to start off by pressing Control Divide, so it brings up this fraction. Because the quadratic formula is just a big fraction. So I got negative 64. I'm going to do the plus, because it's a plus or minus. So I'm going to do the plus square root 64 squared minus 4 times a is going to be negative 16 times c is 0. So that's going to turn all that to 0. Divided by 2 times negative 16, negative 32. Okay, so it comes out to be 0, and that is fine. So one of my answers is 0, just like I determined over here. You can kind of see it in the top part of the screen, right there. Okay, t equals 0, so that's one of the answers. Now that was the plus from the quadratic formula. Now I'm going to go ahead and do the minus. All right, so I'm going to do the same thing. I'm going to get the negative now. Okay, and 4. And as you saw when I factored it, there's your t equals 0 and there's your t equals 4. So sure enough, the quadratic formula does work on this as well. And again, I just want to emphasize it always works. So when is the arrow 32 feet? It's 32 feet at t equals 0 seconds and 4 seconds. Oops. T equals 0 and t equals 4. Okay. So let me zoom back out real quick. All right, let's keep going through this thing. What is the maximum height of the arrow? So to find the maximum height, you're really interested in finding the vertex. So I'm going to go ahead and find the vertex to find the maximum height of the arrow. And I talked to you guys about doing negative b over 2a to find the x value of the vertex. So using this equation right here, negative b is negative 64 over 2a is 2 times negative 16, so that's negative 32. And that equals 2. And that gets me the x value of the vertex. And if you have trouble remembering negative b over 2a, remember it comes from the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. If you get rid of this discriminant portion, you have negative b over 2a left over. And that's where this is coming from. So negative b over 2a from this original equation is what gets me the x value on the vertex. And if I take the x value and I plug it back into this original equation, then I'll also get the height. So what this is saying is that it takes 2 seconds to reach the maximum height. And we don't know what the height is yet until we plug it in. So 2 squared, that's 4 times negative 16. Then plus 64 times 2 plus 32. It all comes out to be 96. So after 2 seconds, the arrow reaches a maximum height of 96 feet. Okay, so what is the maximum height of the arrow? 96 feet. How long does it take to reach the maximum height? 2 seconds. What does the vertex mean in this case? So you could write something along the lines of, it takes 2 seconds for the arrow to reach a maximum height of 96 feet. Okay, something along those lines. Okay, so going on, what is the y-intercept? Algebraically, the y-intercept, I mean, think about it graphically. This is what it looks like. The y-intercept is where this thing goes up and it hits the y-axis, which means x equals 0 there. That's the only place that x equals 0. So it's one of the easiest things to solve for. When you look up here, to solve for the y-intercept, you just plug in 0 for all of your x's, or in this case, t's. So 64 times 0 is 0. Minus 16 times 0 squared is 0. So 32 is going to be my y-intercept. It's as simple as that. So plug in 0 for your x's. 32 is what's left over. What does the y-intercept mean in this case? Well, it means that when time is 0, it starts 32 feet high. That means when this arrow is shot, you're shooting it off of a building, you're shooting it off of a tree, maybe you're shooting it off of a 32-foot tall ladder, something of that effect. But the point is, when that arrow is shot, when time is 0, it's 32 feet high. What does the y-intercept mean in this case? Okay, we just did that. How long is the arrow in the air? To solve that, you need to find the roots, okay? So again, just visualizing what's going on. How long is this arrow in the air? Well, it gets shot like this, comes down, something like that, right? That's 32 feet high. How long is it in the air? Well, you're looking for your zeros. This and this point. Now, this point right here, that's a pointless 0 because it's actually a negative time. So it makes no sense in the context of this real actual question, okay? But this one, that's the one we're looking for. That's when it hits the ground. Okay, so to find out how long it's in the air, we find all the x values from here all the way to there, whatever that time is. All right, so to do that, again, the height is 0. So you're going back up here. So notice, I need to clarify that. The y value for both of these x-intercepts is 0. So to find both of those x-intercepts, I need to plug 0 in for y right here. All right, so I'm going to write that on this piece of paper. I'm just going to cover this all up. I'm going to work it out right here. So I've got right here, 0 equals, okay, 32 plus 64t. I'm actually going to switch it all up. So negative 16t squared, negative 16t squared, plus 64t, plus 32. So we need to set it equal to 0 before we use the quadratic formula. It's already set equal to 0. So now I'm just plugging it in. Negative b plus or minus the square root of b squared minus 4 times a times c, all of it over 2 times a. So negative 32. All right, again, if I take that and I plug it directly into my calculator, and I've already done it, so I'm just going to, instead of doing all that again, here it is. Here's the negative 64 plus, so I'll zoom in. Here's the negative 64 plus the square root of the discriminant, and then divided by negative 32. Here's negative 64 minus square root, all the discriminant, divided by negative 32. And those are my two zeros. Again, this one doesn't mean anything because it's negative, and that's talking about negative time. This is how long it's actually in the air. All right, so I'm going to take that, and I'm going to write how long is the arrow actually in the air? 4.49, or 449, sorry. 4.4, let me zoom out. 4.449 seconds. Okay. What are the roots of the graph? Well, we found out just a second ago it was negative 0.45 pretty much, comma 0, which that was the pointless one. And it was 4.449 or 4.45 comma 0. And that's the one representing when the actual arrow ends its flight. So what do the roots represent in this case? Well, that one doesn't represent much. That's the landing time of the arrow. Will the arrow ever reach a maximum height of 98 feet? Well, we found that the maximum height, because the vertex is either a maximum or minimum, was 96 feet. So, no. The vertex shows that the maximum height is only going to be 96 feet, and it can't reach 98. All right, guys. Let me know if you have any questions, and I hope this video helps.